Hello, my name is Chis Zidik. I'm the Forest Health/Stewardship Field Assistant for 2022, and I'll be talking to you about CTSG 2KK. CTSG stands for Conservation Tree and Shrub Group, which is a group of soil types with similar climatic and edaphic characteristics that control selection and growth of trees and shrubs. I'll be focusing on the subgroup 2KK. So what does 2KK mean? If we take a look at the NRCS field guide, we see that the number 2 tells us that the soils have high water tables. We can then look through the criteria below for more detail. We see that these soils have bedrock that is very deep, the drainage is somewhat poorly drained or poorly drained, and we have carbonates and salinity present in the soils. That's what the 2 in 2KK tells us, but what about the KK? K is a letter suffix that tells us calcium carbonate is present in the soil. 2K is used for soil series with 5 to 15% calcium carbonate equivalent, while 2KK is used for soil series with 15 to 40% calcium carbonate equivalent. This criteria matches eric calcialkals, which means when we are looking for soils that are in CTSG 2KK, we are looking for eric calcialkals. Let's break down this taxonomic name. Aquals denotes that the soil is of the mollisol order. Calci is a prefix that tells us calcium carbonate is prevalent in the soil. And lastly, eric means that the soil has been exposed to air over long periods of time. This makes the color of the soil brighter. It can even change the color of the subsoil from a gray silver to a gold in the form of redoxomorphic features. This means that the iron in the soil has oxidized, turning the soil into the golden color, which we can see in these images. The soil profiles on the left are showing typical horizonation and color for 2KK soils. We can compare the soil profile maps of Divide and Hammerly series with the actual soil core on the left and see the similarities. The image on the right is a large pit revealing the same profile as well as the golden color that we normally look for. Soil scientists drop dilute hydrochloric acid onto these soils as a diagnostic field test. The calcium carbonate reacts with the hydrochloric acid in an effervescent reaction. So, if we were to drop the HCl on 2KK soil, we should see none to strong effervescence in the surface layer and a violent effervescence in the subsoil. The more carbonate in the soil, the more violent the reaction. Since 2KK is a classification of multiple soil types, we have to use Soil Web Survey in order to find potential areas to survey. Soil Web Survey is a useful tool that uses NRCS transect data and landscape morphology to map relative soil types over a satellite image. Since these lines are not definite, we need to use field and lab techniques to conclude whether a soil is 2KK or not. The image to the right is a soil scientist pulling the soil probe where we have found a 2KK soil. We can compare this image from the field with the image on the left from the field diagnostic booklet, and we see that we have a match. The next test would be dropping that HCl on each horizon. But how does all of this form? But we have to look at the geologic history to figure that out. East of the Missouri Coteau was most recently glaciated about 10,000 years ago. The glaciers churned up rock and soil along its entire path, sometimes bringing material all the way from the Canadian Shield. 2KK prone soils have a calcareous, loamy glacial till as the parent material. Calcareous meaning that it contains calcium carbonate, and glacial till meaning that the material was a mixture. There was no horizonation yet. That's how the material got to North Dakota, but how did the morphology play into it? As the ice sheets receded, chunks of ice broke off and became covered, and in turn insulated by glacial drift. The slow melting of these chunks formed depressions in the landscape. This process created the many potholes of the till plain in North Dakota. The potholes caused repeating topographical sequences which weathered and developed similarly. These repeating topo sequences formed katinas, which are a chain of distinct but co-evolving soils stacked along a slope. Although the parent material is the same, different slope position and in turn weathering conditions formed different soils. We can use this knowledge as a predictor of where to find 2KK soil. The best place for us to look for 2KK soils are slightly upslope of a wetland. We are looking for the less than 3% slope that's not too high and dry, but not too wet either. Over thousands of years, along the slope of the Katina, the water table would rise and lower through these soils. This dragged carbonates up through discharge hydrology and formed the B horizon with a range of 15 to 40% calcium carbonate, within 16 inches of the surface. A great example of this is the dominant Hammerly series, which is extremely common in the till plain. Hammerly soils are found on the slight rise off of a wetter soil like Tonka or Valor series. In my personal experience, I was able to find Eric calcialkaloids frequently on a Hammerly map unit. We can put all of this information together and use our understanding to have a higher efficiency when looking for sampling sites of 2KK soils. In this image, we can see a tree row that undulates with the landscape. The trees in the lowest and wettest part of the landscape are fully dead, which we can easily see. The trees on top of the hill stay relatively dry, while the trees in between are within our target area. If we have checked Soil Web Survey to ensure we have the correct soil type, this should be a good place to collect a sample. Now that we know the conditions needed for 2KK classification, as well as the background information on the formation of 2KK soils, we can start to form a picture of what soils like this look like from the field. Looking at this picture, we can see a landscape with very low relief. We also notice the difference in vegetation as the lighter canary reed grass is growing in the wetter soil. This is useful information because we remember that CTSGs are soil types that are grouped based on how they limit the growth of vegetation. A couple yards upslope of this boundary would be a good place to probe. This image is exhibiting similar features of very low relief and limited tree growth. We can also notice an unplanted section of crop to the left of the trees. Why would this be unplanted? The site, most likely, was too wet to plant, telling us that the trees are within the 2KK sweet spot that we learned about earlier. We can see a noticeable difference in tree health throughout the row, as trees on the left are in significantly worse condition than the trees on the right. Throughout all of these pictures, we are seeing the common themes of low relief, very slight slopes, vegetation constraints, and impacted tree health. It is typical to see declines in height and crown density when observing trees growing on CTSG 2KK. Although all of this is valuable information, it does not guarantee finding 2KK. The collection of techniques and knowledge will guide you towards a more efficient field season. Lastly, my personal favorite method of identifying Eric calcialkaloid soil is when a tree has uprooted and given you a gift. No probing needed, just drop some HCl on the horizons and collect your sample.